I'm JK and my channel is JK Solutions. Given that one is to distribute high power or huge electrical power, then it has to be done at 11 kV or more. It has to be so because of the constraints that will be encountered if one makes any attempt to do so at low voltage. At low voltage, one is bound to encounter the constraint of or the limitations of the sizes of the low voltage circuit breakers, as well as the bus bar, the sizes of the bus bars as well. So now, making use of the medium voltage, which is 11 kV or more, to do that distribution of high power, such as 4 MVA in this situation, and as we are going to see. So let's move on and see the concept, as we are going to make use of an example to illustrate it. Alright, this is the power. The apparent power required is 4 MVA. That is the power to be distributed. Alright, so now let me explain the concept first. We have the mains section, okay, and we have the generator section. Then we have the automatic or changeover / interlock panel at 11 kV, which is medium voltage, and we have this green bar, which is this green bar rather, which is the common bus section, and this green bar here is the interlock. This one here, 11 kV motorized interlock. So it's motorized. So one just needs to press buttons. All right. Then looking at the common bus section here, then we have the load, which is indicated by this RMU ring, as well as RMU. Then we have the step down transformer here, okay, SD, S/D means step down transformer. Then we have feeder pillar. Then we have this meanings to this abbreviation. RMU means ring main unit, and TS means transformer. So the concept here is that we have 11 kV supply here. All right, this is 11 kV. 11 kV supply, and we are to distribute 4 MVA. That is, the load requirement or the power requirement is 4 MVA. Now it is wise to have these two number 1.5 MVA generators, and then we have another generator which is G3, that is 1 MVA. Alright, so then we have 500 kVA. So these three generators can give us 4 MVA, and we have this 500 kVA to be just the excess power above what is required, because it's not all the time that the power requirement will remain constant at 4 MVA. At times it could be maybe these two generators, G1 and G2, that will be working or operating, or it could be just one of them, or just any combination of the generators. So we have this MCCB panel. Nothing more, it's just an enclosure there to house the MCCB. This circuit breaker, model case circuit breakers. We have MCCB 1, 2, 3, 4. So this is IP65, okay, IP65 panel. So ingress protection is IP65 so that rains will not be able to enter. Then the main peculiarity here compared to what I've been producing since is that we have one transformer to one generator. So this is a step up transformer. That is the meaning of TXSU, transformer step up, okay, or step up transformer. So this one is 2 MVA, is stepping up the output of this generator. This 1.5 MVA. So 2 MVA, 1250 kVA, and 800 kVA for the 500 kVA generator. Now this side is LV side. Then we have the medium voltage side, which is 11 kV in this situation. So we have 11 kV here. Okay, that is the secondary voltage. Okay, then we now come here. The synchronization of the output of the generators is done at 11 kV. That's why this panel, MVP, medium voltage panel P, or this medium voltage panel MVP, is 11 kV AMF phase slash phase sequence slash load shedding slash synchronizing panel. So the difference between this one and what I've been doing before is that the synchronization is done at 11 kV, which is a medium voltage, and both the synchronization of the generator and the paralleling of the transformers, the 4 transformers, the paralleling is also done at 11 kV. Then from there, power is delivered to the 11 kV panel or the interlock panel through this circuit breaker. Then when power is delivered, definitely power is available on the generator side of the 11 kV panel, which is the interlock panel in this situation. Medium voltage 11 kV automatic changeover slash interlock panel. Now, when there is interruption in the voltage supply, there is automatic or remote sensing signal to this panel, to the AMF and all this panel. This panel MVP. There is this signal into it. So there is power. There is mains failure here. Okay. When that occurs, we have signal lines S1, 2, 3, 4. This is the continuation of those S1 to 4 is S1, 2, S3. Yeah. So when there is mains failure here, the remote sensing is done to the AMF panel or the synchronizing panel, and there are signals to the generators to start. When they start, of course, the panel, this 11 kV panel or the synchronizing panel at medium voltage, determines the amount of load that is actually required at a particular time. Alright, and that, through that, the number of generators to be switched on is known. So when that happens, power is available here, and this circuit breaker will close. When this one closes, this one opens immediately. The two should not open at the same time. Okay, this for the gen side, this for the main side. That's why we called it interlock, but it's motorized. It's operated through the use of buttons, close coil and or close button and the opening button. Then we have circuit breaker PCB. means circuit breaker. All the 11 kV circuit breakers are VCB. They are all vacuum circuit breakers. Now, this is a metering unit for the generator side, and this is the metering unit for the main side. Alright, so when power is available at the common bus section here, then power is made available to this ring main unit ring, and then we have RMU, 4 of them. From there we have step down transformer, okay, SD, that's step down transformer. Then from there we have the feeder pillar. From the feeder pillar we can have supply to low voltage MCCB panels within the building or wherever they are required. Okay, the panels are fed. Now, when the main supply is restored, this this circuit breaker will be closed. This circuit breaker will close. So, and simultaneously there is remote sensing to the panels, and the panel signals to the generator to shut them down. So, and simultaneously as this one is closing, this one is opening. Alright, and then that is the situation. That's how it is. So that's how to have the successful distribution at medium voltage, which is 11 kV in this situation. Thank you for watching. Now please, you must have found the video useful. If that is so, please consider subscribing to my JK Solutions channel. Thank you.